Hey everyone, so in this video we're going to look at compound inequalities and how to solve them. We're going to see two flavors, and a compound inequality is where there's more than one inequality in the problem. I tend to call these ones continued inequalities, and I tend to call these ones compound. This text that we're using calls them both compound. I've seen it both ways in different books. But the basic two flavors are there's one where it's going to be contained. So like for this particular inequality, they're saying that the x's are going to be bigger than 2, but at the same time they're going to be less than 5. There's a way of thinking of that as two overlapping sets. I'm not going to worry about that in this course, and we'll just kind of go straight to the answer here that the x has to stay between 2 and 5. And then there's this other kind where it's going to be using an or, and that's where you're going to see two separate solution sets. In the next class, probably 141, if you're in this one, there's some problems where one version of a problem, it's absolute value equations or absolute value problems involving inequalities, where the solution will come up as one of these, and then another flavor where it will come up as one of those. So right now we're just kind of getting used to the idea that these two things can happen. They are not too bad. Let me get going and show you how these would work. So for this first one, we're asked to graph this in then interval notation again. And these are things that we saw in the last section, but just to kind of get us going. For here, we'd have the 2 and the 5. The 2's an equals, so remember from our last section, when there's an equals, we use a solid dot to denote the equals. And when there isn't an equals, that's going to be an open dot. And this is saying the x is going to be bigger than 2, but at that same time, it's going to stay less than 5. In other words, it's going to be right in between those two. It looks kind of the exact same as the inequality looks, where the x is kind of sandwiched between the numbers. So inequality for this would be from 2 up through 5, and then not including the 5, so we use a parenthesis there. We saw these in the last section as well. For this one, we have x can be less than or equal to -3. So we'd have a solid dot here, and then less than or equal to, so we're heading in the negative direction. Or x can be greater than 1, so that would be an open dot, and then greater than 1 would be this side. So in terms of interval notation, we would need to use a union on this one because we have two unconnected solution sets. So we would go from -infinity. Remember, we always go from the smallest to the largest, where we work left to right. So -infinity up to -3 with a bracket, and then we use that union symbol to paste these two solutions together, and from 1 to infinity. So that's the form that our answers are going to take, and then the rest of this is a little bit more complicated versions of each of these setups. It's all math we've done, we just haven't seen it quite in this format. So for number 13 here, same thing, we're going to solve the inequality, graph the solution, give the answer in interval notation. But so here you can see instead of just an x in between a couple of values, now we actually have an expression in there. You already know how to solve this. It's the exact same math. If you pretended for a second that this -7, this whole piece over here wasn't there, the way that you would solve what remains is the exact same thing you're going to do even when it's a continued inequality like this one. So if it was just 2x plus 3, let me write that out down here, less than 13, the first thing you would do is subtract over the 3, and then you would divide the 2. Nothing changes with this other piece. We still do that, but now we're going to do this in 3 places instead of just both sides. We have to do it in all 3 sides essentially. So we'd subtract our 3 just as we would have before, and the only difference is now we have to do it with both the -7, the expression, and the 13. So here we get -10 less than or equal to 2x less than no equal to 10. And then here, if that wasn't there, we would divide by 2. That's exactly what we do even though it is there. We just do it in all 3 places. So solution set goes from -5 is going to be less than or equal to x is going to be less than 5. And so in terms of our graph, that's pretty much a whole graph there. So this side we get a solid dot. That side would get an open dot, and then it would be everything in between those values, because the x is staying greater than or equal to -5 while also staying less than the +5. And then interval notation, hopefully this is getting easy at this point. We would just go from -5 with a bracket to +5 with a parenthesis. So this next one is basically the same thing, except there's that, notice the negative on the 9x. And that's that thing we saw in the last section, where if we end up dividing by a negative, we need to be careful and reverse all the inequalities. So same situation here. So we'll start off by adding the 3 everywhere. Again, if you get kind of mixed up on what to do, cover up that piece of it and just think, what would you do if it was this much? We would add the 3, and so that is still a good plan. So -30 plus 3 would give us -27, less than or equal to -9x, and then less than 9. And then next we would be dividing out that -9, and that's where we just have to be a little careful because we're dividing by a negative number. And with inequalities, that means we have to reverse the direction of the inequality symbol. So that will be -27 divided by -9 would make a +3, but now this is greater than or equal to x, and 9 divided by -9 would make -1, but again we would have to reverse this symbol for -1. And right now that's written a little backwards. I can write this exact same thing. I want to maintain, so here the x is greater than -1 but less than 3. I can rewrite this in this other order. I always think of it, I look at it, I think, okay, the pointy part is facing 1, so I make sure that I maintain that, which is the same thing as saying x is greater than -1. I just find it easier to, if the pointy part's facing -1, keeping it that way. Likewise here, the pointy part is facing x, so I'm just maintaining that same thing. So these are absolutely equivalent expressions. This one's just kind of written in backwards order. It makes it a little harder to see. And that's because we divided through by that negative. So in terms of our graph, -1 is an open dot. 3 is going to be a closed dot. And our solution set is the stuff in between. And for interval notation, we go from -1 up to 3 and inclusive on the 3. So here's the kind with the or. I wish that was spaced a little bit better, but that's how it looks on the homework. Same basic directions. For this, we're going to, actually, let me go ahead and write this out down here so it's a little bit bigger. We'll do or, oops, 2 plus 2x greater than or equal to 10x plus 2. So we're just going to treat these as 2 separate inequalities, and we'll get one solution over here, the other solution over there, and then we'll graph those and write our answer. So just as we've done in previous sections, I'm going to subtract the 6x over. Again, whenever I can, I prefer to bring the x's to the left of the inequality just because it feels like it's in a better order. And then we'll add that 4 over, and that'll get us 4x is greater than 8. And then dividing both sides by 4, it's +4, so there's no sign flip. I would get x is greater than 2. And then the other choice over here is, let's bring the 10x over. So that would give me 2 and then minus 8x. So there's that negative that we're going to have to be careful and get that flipped. Greater than or equal to, that's gone. So that would be 2. Okay, so subtracting 2 on both sides. That gives me -8x is greater than or equal to 0. And I'm still dividing by a negative right there. And so even though we can kind of see x is going to be involved with that 0, when we divide by the negative, we still do have to flip the inequality. So that's going to be x is less than or equal to 0. So coming back to our number line, x's are greater than 2, so that would be an open dot. And again, you can think of the arrow on the graph kind of going the same way as the inequality, if that helps. So there's our x's that are greater than 2. Get rid of, oops. And then here, x's are less than or equal to 0. So I want to use a solid dot there. That look like that. So for interval notation, we're starting at negative infinity because we start on the far left. Go up to 0. Use a bracket because of the solid dot and the equals. And then we'll union that with 2 to infinity. And let's see, last example, just slightly more complicated equation over here. So 3x, I'll bring that over, and that will give me, subtracting 3x on both sides, gives me 5x plus 11 is less than 1. We'll subtract the 11 over. That's going to be 5x is less than negative 10, and then divide both sides by 5. And then x is less than negative 2. And again, I didn't divide by a negative. I got a negative number, but I divided by a positive, so no flip of the sign there. For this, as I write it out, I'm going to go ahead and distribute that 3 and clear my parentheses. So that will give me negative 21x. 3 times negative 5 will be negative 15. And then minus 6. Just copy down the rest of it. From here, we got a couple of like terms. Let's put those together because it's a good habit. That'll be minus 21 right there. And then I would add the 12x to this side. And while we're here, doc's going to come crashing through behind me. Let's add the 21 over to this side. Now I'll get my x's to the left and my constants to the right. So those cancel, and then negative 21 plus 12, that'd be 9x negative. And on this side, that's gone, and then negative 12 plus 21 will give me a positive 9 over here. This time I am dividing by a negative, so that's going to reverse the inequality. So it's going to be x is greater than or equal to negative 1. So up on my number line, I want x's to be less than negative 2. That would look something like that. And x's are greater than or equal to negative 1, so that's going to be a solid dot right there. And then we're heading off this way. Interval notation, we're starting at negative infinity, going up to negative 2. And that's a parenthesis, and then because we have that gap, we're going to use our union, and then bracket because of the solid dot, so negative 1, and out to infinity. And that wraps up inequalities.